the critical angle now. The critical angle is the angle of incidence when the angle of refraction is equal to 90 degrees. So this angle of incidence down here, when the angle of refraction in this point is 90 degrees, then this angle of incidence is given a special name, which is the critical angle. Welcome to another tutorial of Proflan YouTube channel. In this particular video, we're going to have a discussion on the most important formulas that you must know before you go and sit for your exam. We're going to look at the most important formulas that you must know before you sit for your exam. We understand that at the beginning of your exam paper, we understand from the beginning of your exam paper, there are actually formulas which are provided. But there is a list of 10 formulas which I'm going to highlight in this particular video, which you will not be provided, and then you are expected to memorize them so that you can be able to answer questions in that coming exam. And if you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload further tutorials, you'll be notified. As you are doing your IGCSE, remember you are going to transition to A levels. I'll be able to walk you the journey even when you are doing your A levels. So you have every reason to subscribe in Proflan YouTube channel so that we can be able to grow this channel together, and also you are going to benefit. Right, so one of the formula that you are going to look at, or the formula that you must memorize before you go to that examination, is the formula to work out density of a material. So you'll be expected to remember that density equals to mass over volume. So that's one of the formula that you ought to remember before you sit for that exam. Number two, you need to remember the formula for working out pressure in solids, and also pressure in liquids or fluids. So first, for density is equals to mass over volume. So that is what you need to remember. So if you are working out density of a material, maybe you are giving density in kilogram per meter cubic. These are actually the units. The units for density will be kilogram per meter cubic, or you will be expected to give in grams per centimeter cubic. So this is one of the formula you know to be provided in your formula sheet when you'll be doing or sitting for this paper. So the second formula that you need also to understand is the formula to calculate pressure. And we know that pressure is actually the force per unit area. So we know that pressure equals to force exerted over area in contact. So this formula also becomes very, very important because if you are given the force and you know the area, you can be able to work out the pressure in that case. So one of the question that usually arise here is maybe when you are told a person standing can be able to exert a given pressure in the ground. So you may be expected to describe an experiment on how you can be able to determine the pressure this person exerts on the ground. So remember, you need to know the force, and the force is going to be the weight of the person, and the area in contact is the area of the foot. So meaning that if you are supposed to describe how to get the area of the foot, you are going to draw an outline of the foot of that person, and then on a squared paper, then you count the number of squares. So you can be able to count the number of squares. And remember, area is going to be equal to the total number of squares times the area of one square. So that one you need to remember that. So because if we are counting number of squares, we are going to say full squares plus a half, those that are incomplete, those that are incomplete squares. Then you now want to get the area of the foot. You find the area of one square times the answer that you must have obtained at that given point. So pressure in solids, you're going to use this formula at this given point. So another formula also that you not be provided is a formula to calculate pressure in fluids, and that is a pressure in liquids or fluids is actually pressure equals to height of the liquid column times the density of the liquid or the fluid times the gravitational field strength. So that one, now suppose we have a liquid that is in a measuring cylinder. We want to work out the pressure exerted at the base of this measuring cylinder. It means we need to know the height above this base, and this is going to be our h, and then we must know the density of this particular liquid so that we can be able to multiply here, and then we know the gravitational field strength, which is usually 10 Newton per kilogram. So this constant you will be provided, but you need to remember now, if in this kind of a question you are told there is atmospheric pressure that is acting here, so we are going to consider also the atmospheric pressure. So you need to be very, very open on the way the questions are actually asked. So pressure at the bottom, now if there is atmospheric pressure, we are going to say pressure at the bottom is going to be h rho g, which is height times density times gravity, then plus atmospheric pressure. Now that is specifically if you are told there is atmospheric pressure. So something else that you need also to understand, and I feel that is quite important for us to mention when we are talking about a YouTube manometer. So this is another concept that I've seen being asked in some of the IGCSE EDEXCEL question. So if we have, for instance, gas pressure at this point, so which means that we are going to have a given liquid which is at this given tube. So this liquid is being supported at that level by the presence of this gas that is at this given point. So which will mean that if we are working out the pressure of the gas, this is going, you have to check what's the height difference between the two levels of the liquids, right, at that given point. So we must know the height. So but at the same time, from here there is atmospheric pressure acting from this end, right? So meaning that now gas pressure, feel that this pen is really disappointing us. It's not really behaving, it's misbehaving a little bit. So what I'm saying is that now pressure of the gas, let's talk of gas pressure. Gas pressure is going to be what? Gas pressure is going to be pressure due to the liquid column, which is h rho g, height times density times gravity, and the height we're talking is about this, and the density we're talking is the density of the liquid. The gravity is the gravitational field strength. So which will mean that we are going now, because this gas pressure is supporting both this height of the liquid column plus the atmospheric pressure which is acting on the surface of the liquid. So which will mean that gas pressure is going to be equivalent to h rho g plus ATM, which is atmospheric pressure. So in the event you are given a question on this, remember that gas pressure is actually pressure in fluids. This is pressure in liquids. Pressure in liquids is given by this formula that we have here, right? But if we are talking about a manometer, so you've understood what I'm trying to say at this given point. So we need also to look at another formula that is quite important, is the formula of working out acceleration. Remember, we can say acceleration is the rate of change of velocity. So we are going to say that acceleration equals to final velocity minus initial velocity over the time taken. So this is also something that you have to remember. So acceleration units, and the units for this unit is actually meter per second square for acceleration in that case. Yeah. Under motion, you need to also remember that average speed average speed is going to be distance total distance moved divided by time taken. So if you are given a question and you are asked to state the formula connecting average speed, distance moved, and time taken, this is actually the formula they will be asking you to state. So you'll be seeing questions that are asking state the formula that connects given quantities. Basically, in that, the examiner is testing you whether you remember the different formulas that you are introduced to in physics. So we need also to look another formula that you must remember. Another formula that you have to remember is the formula that connects force, mass, and acceleration. So we are going to say force is equals to mass times acceleration, which is force is equals to ma. So this formula is very, very profound in physics. There's no life without this formula. There's no life in the physics world without this particular formula that we have stated here. Force equals to mass times acceleration. So don't forget to also look at the formula that connects velocity or speed of a wave, frequency, and the wavelength. That is now when we shall be talking about the topic of electromagnetic spectrum. You learned the formula for that connect the wave equation. That is to say, the wave equation is wave speed is equals to frequency times wavelength. So this one also you will not be provided. You have to know, you have to remember this formula because you may be expected to use it. Don't forget that frequency also is 1 over t, meaning frequency of a wave is 1 over the period of the wave. These are the formula from waves. This is motion, and also this is motion. And then we have this one for pressure, and this from pressure, and this one is also from pressure. And this is a density of materials. We have already mentioned how to use also that particular formula. Don't forget the formula from work done. Work done. Remember, work is force times distance. So that is also another formula that you really ought to remember before you sit for that exam. Still, we under work power and yeah. So work done, we have already mentioned that. Work done, we have mentioned that. So this is the formula for work done. You need to check which other formula do you really need to remember. We need also to mention the formula for efficiency of machines is useful energy output or power output or energy output over total energy output times 100. So times 100, which is actually equal to this is now when you expressing it in percentages, when you're expressing it in percentages. So this is going to be gravitational potential energy formula. You will not be provided that. You must know that gravitational potential energy is mass times gravity times height, mgh, and this represents the mass, this represents gravity, and this is the height. So something that you need also to remember when you are using this formula is that the units must be in SI units. So this must be in kilograms. This is actually usually 10 Newton per kg, and this should be in meters. So meaning that if the units are not in meters, be very sure to convert that so that you can be able to get all your marks. Another formula that under this area that you must know is the formula to calculate kinetic energy. So kinetic energy is possessed by objects which are in motion. So you need to remember that that is a half times mass times the speed or the velocity squared. So and whenever you are writing these formulas in your exam, make sure you write them in words. You write them in words first, and if you are going to use these initials or these symbols for that, they must be correct. So that's it. And we need also to move to current, electricity. Which are the formulas? Electricity, which are the formulas that you need for current, electricity? Question: one of the formula that you need for current, electricity questions is that this alpha and omega formula for current electricity, which is V equals to IR, which is actually Ohm's law. And this brings us to a point whereby if you are having a graph of velocity against current, if you get a straight line, it means this object is obeying Ohm's law. So it's a straight line because current and voltage are directly proportional to each other. So this formula is very, very, very key because you can be able to rearrange it in different ways so that you can be able to work out different quantities here. Remember, from here we can say resistance is R equals to V over I in that given point. So remember, even this from the velocity, from the voltage current graph, you are going, if you work out the gradient, that's going to give you the resistance of a given material. Now, on that note, different graphs that we are going to have here. If you are talking of a graph of voltage against current for a bulb, you are going to have a graph that is like that, right? So all right, so another formula under current and electricity that you really need to know, or you must know, another formula for current electricity that you really need to know and must know is electrical energy equals to IVT, meaning current times voltage times time. This is another formula that is very, very important under current electricity. Don't forget that also formulas for power. Power equals to, under electricity, power is equal to current. Power equals to IV. Power is actually IV in electricity, but power under work done. Power under work done. Power under work done is work over time taken. Power is work done over time taken. It's the rate of doing work. And also this formula can be given as power equals to energy over time, the rate of transferring energy. So you need to differentiate power in electricity and also power when we are talking about work done, and also energy transferred, or energy, yes, the rate of energy transferred. So these are key formulas that you need to remember. Also, don't forget that energy equals to QV, right? QV. Don't forget that formula. Don't forget that charge equals to current times time. Charge transferred, electrical charge transferred, is actually equal to current times time. So these are the most important formulas that you have to memorize before that exam, because you may be expected to state them. So I've already mentioned that this one, if they are asked, you are supposed to state the formula connecting. Then they tell you the quantity they want the formula to be all about. So as I'm about to finish, I need also to mention another last formula that you'll be asked, and that is formula to do with refractive index. So we know that refractive index is equals to sine of the angle of incidence divided by the sine of the angle of refraction. So that one also is very important, because you must know that when a wave is moving from one optical medium to another, for instance, this is air and this is glass, then the wave is going to slow down, then it will bend towards the normal. So the angle we have at this point is called the angle of incidence, and the angle that we have at this point is called the angle of refraction. So if you are given a question from this one, they may provide you with this angle. Now suppose they tell you that this angle here is maybe 26 degrees, but this angle down here is not given. Then you are now supposed to use an instrument known as a protractor. You are supposed to use a protractor in order to measure the angle of refraction. So meaning that for you to measure that angle of refraction, you are measuring the angle from the normal. So you have to you have to determine this angle that we have at this given point. You are going to measure this angle that we have here. So while measuring that angle, you place your protractor properly. Let's say, let me extend this a little bit. You position your protractor properly, and you can see now you are going to use the inner scale. The inner scale, now this angle is going to be around 20 degrees. If I can be able to check, this angle is actually 20 degrees. Don't use the outer scale, use the inner scale, because you start from 0, because the other one is starting 0 from there. So ensure you are using the correct scale when you are using your protractor. So meaning that before you go for that exam, you have to ensure that you have a ruler, you have a pencil, you have, for you to draw the graphs, pencil to draw the graph, you have a protractor in case a question from refraction and all another, you are supposed to measure angles. Then you are supposed to have all the apparatus. You have a ruler, you have a protractor, you have your, yes, what? You have your pencil. Ruler, pencil, protractor are the most important apparatus you need as you are proceeding for that particular exam. So the angle of refraction now down here is going to be equivalent to, when I measured this, I got it 20 degrees. So meaning that if you are going to work out, if you are going to work out the refractive index of this material, remember, refractive index is a ratio, so it doesn't have units. So you are going to say refractive index is sine 26 over sine 20. Then you are going to get your answer. All right. So having mentioned the angle of refraction and the angle of incidence, don't forget also to look at the formula for critical angle, the formula that connects the refractive index and the critical angle. But remember, the critical angle is the angle of incidence. Let me just mention this. This might end up save our lives during that exam. So when we are talking about the critical angle, remember, if we are talking of a glass block, we are talking of a glass block, and for total internal conditions, for total internal reflection is just coming in. A condition for total internal reflection to take place, the ray of light must be moving from a dense medium to a less dense medium. So in this region here, this is glass. This is glass, right? And up here, we have air. So when this ray is moving through this, it's moving in a dense medium. So which means when a ray of light is moving from a dense medium to a less dense medium, then total internal reflection will take place if the angle of incidence is greater than the critical angle. And what is the critical angle now? The critical angle is the angle of incidence when the angle of refraction is equal to 90 degrees. So this angle of incidence down here, when the angle of refraction in this point is 90 degrees, then this angle of incidence is given a special name, which is the critical angle. So any given point you have an angle of incidence, any given point you have an angle of incidence, and the ray is moving from a dense medium to a less dense medium, and that angle of incidence is greater than the critical angle, then total internal reflection is going to take place. Conditions for total internal reflection is that the ray must be moving from a dense medium to less dense medium. Condition number one. Condition number two, the angle of incidence must be greater than the critical angle. So that you have to remember that concept before you sit for that exam. So I was talking about the formula that connects critical angle and the refractive index. So the critical angle is going to be sine C, which C is the critical angle, is 1 over n. You use this formula when you are asked to find the critical angle. But if you are finding the refractive index, it means you know the critical angle, then the formula you can use is n equals to 1 over sine C. Then you can be able to get that. So those are the most important formulas that you really have to know before you sit for your exam, and this is in 2 days. So make sure you know how to use the formulas that are highlighted in this video, and keep on practicing until you make it at the end. If you have not watched the full concept predicted question that I put up in the previous video, consider checking them in the description. I've added actually a link to that video, and also in that I've added a link whereby you can be able to download now the marking scheme for that paper, so that you can be able to quickly go through those questions without really, because I know you are really rushing to complete everything for you to be able to perform well in your exam. I really wish you the best of luck in your coming exam that is on Wednesday. Don't forget to come back to Profland YouTube channel to indicate and to talk to us and tell us how did you fare in that particular exam. And I'm really requesting you that you go ahead, share this channel to your friend, recommend it so that they can also benefit from the same. I wish you the best. See you in the next video.